Hey everyone, title of this session is Accelerate POC to Production, OpenStack with Flexpod. My name is David Cain. I'm a reference architect with NetApp.
My name is Mohammed Afzal. I am the engineering architect at Cisco UCS Solution Engineering Group and the lead architect for Flexpod solution.
So I want to give you a little bit of backstory before we talk more about the solution components in here that represent joint engineering work that Afzal, myself, and folks at Red Hat did. So OpenStack is evolving, and what I want to talk about is appliances, so specifically purpose-built appliances, storage, compute, and networking, really simplified deployment in a resulting OpenStack cloud. And what do I mean by that? Well, let's talk about the two classes of users that typically consume OpenStack services, both from a development aspect and an operations aspect. So your developers, really what are they concerned with in an OpenStack cloud? Can I utilize the resources in there? Do I have access to that stuff? They don't really want to be concerned with the aspects of, well, is my solution designed with full HA? Are all my API endpoints construed with software HA? You know, all those building blocks are not really a primary concern for them. They are concerned with building applications and consuming those services in OpenStack. Similarly, as we evolve here, this long journey, this 5-year journey that we've had here in OpenStack, enterprises are starting to take advantage of this. As we heard of in the keynotes, a lot of big businesses are really deploying production workloads on OpenStack. So from an operations perspective, how can I provide an infrastructure as a service for my customers at scale with dependable as well as scalable infrastructure? How do I monitor that? What's the life cycle associated with those components? How do I do upgrades? And most importantly, support. If I don't have staff that know how to delve into the nuances of Neutron, or that know how to scale, storage out or scale compute up and out, who do I call to help me with that? Can we make both development and operations happy?
Now the question comes in, why Flexpod? Why OpenStack on Flexpod? There are several reasons behind it. Flexpod is a trusted architecture, has been proven in many other virtual infrastructures, whether VMware, Hyper-V. So now we are going into the OpenStack so that we can provide highly available, flexible and scalable architecture that has been proven and tested, that also reduces risk and make repeatable and consistent deployment. Not only that, you can scale out without any disruption. And its core architecture is comprised of Cisco UCS servers, Nexus switches, and also the Nexus 1000 vSwitch for the virtual switch environment, NetApp storage, and E-series storage, and also for bare metal servers and hypervisors.
So how does Flexpod make OpenStack easier? Well, we like to say that this year we've actually just celebrated our 5th anniversary with Flexpod. With almost $6 billion in revenue over 5 years, it's a very dependable and trusted platform for other things, as Afzal mentioned, VMware deployments, Hyper-V, but now with OpenStack. In this solution, we'll take you through some of the elements of how our various companies represented in the solution make OpenStack better and easily more consumable. But in this solution, there's proven and trusted technology there between Red Hat, NetApp, and Cisco. We have engineered integration in RHEL-OSP through their installer product and RHEL-OSP 6, which is based off Juno. But we also have engineered integration in RHEL-OSP 7, which is based off Kilo in their Director installer product. And also, as I mentioned earlier about support, Flexpod, myself and Afzal, we worked pretty tirelessly on the Cisco validated design that's been released for this architecture that's out there. But through the life cycle of Flexpod, we have about 100 validated designs, both Cisco validated designs and NetApp verified architectures on that platform. So I want to delve a little bit into some more deeper technical. I want to give you guys some technical and less markety slides. I know it's the last vBrownbag of the day. Let me try to get a little bit deeper into the weeds here with the technology. I want to talk about two things from a storage perspective. One is our Cinder storage service catalog from NetApp. Really what that means is our resulting Cinder volumes that we deploy in the OpenStack cloud. Typically with Cinder in the scheduler, it's a random selection algorithm as to where those Cinder volumes end up. With this functionality being taken advantage of through the extra specs library with Cinder volume types, we can actually expose NetApp value proposition all the way up to the users in the OpenStack cloud. And what does that mean? Well, those resulting Cinder volumes that we use for persistent instances that boot in the cloud, we can take advantage of having those Cinder volumes be backed by all flash disks. Or maybe we have a situation where a customer wants to deploy Cinder volumes and the eventual instances on volumes that are snap mirrored or have mirroring enabled between different data centers. Well, we can do that with this functionality. As you see here in this chart, I apologize, it's a little bit busy, but the volume types, archive data, general purpose, transactional DB, these are just strings that represent, you can call them anything there, but the point being, you associate a volume type with extra specs, and the resulting Cinder volumes are deployed on those specific volumes that have those specifications on that NetApp storage. Instance caching, that's another thing I want to bring up here that's very compelling in this solution. With our unified Cinder driver that's deployed automatically through the either RHEL-OSP installer or RHEL-OSP director, our unified driver is deployed that really adds value there from a Cinder perspective. So when you store your Cinder volumes on NetApp FAS with our driver, if you look from the Linux perspective there, you do a df-h on that volume. The first copy that's made from a glance image to a Cinder volume is actually cached in that NetApp's FlexFall. Resulting Cinder volumes are cloned. So it's a point-in-time copy with NetApp Flex Clone technology. And really, that's very compelling. Instead of having 20 gig copies, 20 gig copies, 20 gig copies, we're actually utilizing the FlexClone technology and storing the differences between those instances that are booted up, by only storing the deltas between those disks. So we're utilizing pointers in the back end of our operating system and doing that very efficiently. And so the differences only take up new blocks on disk rather than, taking up the entire 20 gigs for those resulting instances. And in testing, we FlexClone 20 gigs in 0.3 seconds. And I can tell you, in the validation out there in the lab, we did 1,000 instances with 8 compute nodes in 26 minutes. We had fully booted in an OpenStack cloud, ready to go. They had 100 gig root disks, 26 minutes.
In this solution, we also integrated Nexus 1000V for KVM. Nexus 1000V has been added in many other Flexpod solutions as well. As I earlier mentioned that the Flexpod has been deployed in thousands and thousands of customers' site already, being a trusted architecture. So here the Nexus 1000V is bringing the same modular architecture that we have in Cisco switches, where the supervisor module, dual supervisor module, and the line carders are involved, whether you're talking about Catalyst or 7K or any other modular switch. Cisco Nexus 1000V bring the same capability in this architecture. Your virtual supervisor module run as a VM, which is the control plane of your switching environment at the virtual layer, and also the virtual Ethernet module, which acts as a remote line card. So you have a connectivity, a layer 3 connectivity between the virtual supervisor module and the virtual Ethernet module for control traffic, and virtual Ethernet module maintains the data plane to provide the switching network for the VMs connected to it. The biggest benefit of having Nexus 1000V in this architecture, it actually gives you the same familiarity, the level of usage that you already have in any other architecture. For example, if you have Nexus 9000 upstream, so you're using the same Annex OS architecture, same configuration mechanism, so there is no learning curve involved, and it also segregates the duties of responsibilities between the server admin and the network admin. So your network admin have a full control over to your virtual switching environment as well, rather than your server admin controls the virtual switching environment. On top of that, you can also leverage any other tools that you are leveraging in your data center for monitoring, for any other things that you can leverage in Nexus 1000V as well. This slide actually mentions how the Nexus 1000V workflow works in OpenStack environment. So as a network admin, the network admin logs in, just like he logs in any other modular switch, Nexus 9000 or 7000, he creates policy profile. By creating a policy profile, he can also attach any security policy and groups if he wants to. These policy profiles get pushed into the OpenStack Neutron using N1KV plugin. And when the tenant logs in or the cloud admin logs in, that policy profile is available in Horizon. So when the VM is provisioned, the ports are created, that policy profile can be attached to that port. And after that policy profile has been attached, and when the VM is created, the configuration data is pushed from VSM, Virtual Supervisor Module, to the Virtual Ethernet Module. So this way, this whole workflow works, and you can even later on add more security policies to the policy profile that a network admin has created. And instead of using security groups in OpenStack, you can leverage the overall ACL and any other quality of services that are available in any classical switch that you can leverage in virtual infrastructure.
And I just want to mention also, I mentioned support earlier. Well, we have cooperative support between the three companies, and really what does that mean? If you're comfortable with calling NetApp for any support issues here, you can call us. And if you have a problem that's determined to be a Red Hat problem or a Cisco problem, we handle the resolution of that with you with a seamless handoff. You know, we have labs built that help recreate problems for you, but also it gives, you know, the customer peace of mind in knowing that they're not going to be transferred to say, oh, call the other vendor, that's not our problem. So really that's the quote unquote one throat to choke, but really helps the handoff of support cases should you have issues.
Yeah, it's a joint solution with Red Hat, NetApp, and Cisco. So for end customer, it's a single point of contact for taking care of any issues that comes in and the level of escalation if needed, whether it's on the Red Hat side or on the Cisco side or on the NetApp side. So you get a single point of support mechanism which offloads a lot of risk from the customer resolving issues.
That's right. So finally, a call to action. If you want to take a picture of this slide here. Otherwise, these slides will be available later. I promise to upload them to this session if you'd like to look at them. So even if you don't want to take a picture of this, but the design, the deployment guides are both listed here in the URLs. And our Data Fabric Starter Kit, that's a PDF that's there that you could use to start off and kick off. It's a subset of the CVD, but it's a much easier distribution mechanism to take some of the components in there to really start your journey in bringing from POC to production in OpenStack.
And the CVD is already out there. It actually explains step-by-step guide to deploy OpenStack without facing any problem and risk that we already faced in our lab environment.
Yep. So thank you all, and we'll be available back there if you have any questions.
Thank you, everyone.